Hey everyone, on to day 12 of Advent of Code. I'll try to get out the day 6 through day 10 recap on my Substack soon, but we will see. Oh, interesting. This looks like a grid type problem. Yeah, a lot of interesting things going on here. All right. What are we doing? There's regions. We need to figure out area and perimeter. Okay. Got it. That seems relatively easy. The perimeter is the number of sides that do not touch another garden plot. Oh, okay. How do I understand that? So, okay. Yeah, okay. So I think I can just do times 4 and then subtract 2 for each neighbor pairing. Yeah, that seems doable. Okay, so a region is that region's area by its perimeter. The total is... Okay, got it. Cool. So the actual numbers don't seem to matter much here. So I will just turn them all into ints. Given they're all capital letters, I'll do minus a because a is the lowest letter. Cool. So now what do I want to do? I think the key is each time we just want to flood once. Yeah, so we do like while true. Actually, let's not do this boolean. Stop equals false. While we don't want to stop, we will set stop. Stop. I don't know. What do we want to do? We want to do answer. What am I doing? Long val equals, what is it called? It's called flood. I don't remember. Flood grid. If val equals -1, we break. I guess we could have done while true. Otherwise, we'll add it to answer. Okay, cool. So now I obviously have to make the actual flooding algorithm. My basic concept is this. I will treat -1 as already flooded. So I will basically just go until I find something that's not -1. This also does feel like the type of problem where some Python program probably just annihilates me, but that's fine. I'm sure there's some fancy formula for area there, but I wouldn't know the Python package anyway, so no benefit to me. So if the grid is not equal to -1, then we'll set start equal to that coordinate. So we find some coordinate, ij. Yeah, let's actually set this to -1, because then we can do if start.x equal to -1, return -1. Like, we can't find a region, then we just break out of it, right? Okay, but now assuming we do have a region, we'll keep track of a list of coordinates. Oh, neighbor for perimeter is this way, right? Let's just do an example. So we have 1, 2, 3 neighbors. Yeah, that one works. 1, 2, 3 neighbors. So C also has perimeter of 10. Does it say anywhere? Yeah, it does. Okay, cool. List of parameters. List of coordinates. Garden. Apologies if it wasn't a garden. Sure hope it was. Let's actually do a set. I literally always do this, but I don't think, like, we don't want multiple of the same coordinate in a garden. That sounds like something's wrong. Okay. So now we, oh, we should get what the actual garden, like, letter is. So grid, start.x, start.y. I should probably also turn coordinate into a record, whatever. Okay, and then we want to do while true. So let's actually use -2 as the flooded value. So grid start.x start.y equals -2. Right, so then basically what we can do is we look for -2, right? And found equals false. If we don't find it, that means we're done, so we can break. If we do find it, we can add it. Oh, actually, this is kind of dumb, no? We should just do yeah, rather than looping through that, we can loop through garden. So set coordinate new garden equals new hash set, and then for coordinate chord in garden, for coordinate neighbor in, what is it, get neighbors, yeah. So chord.x, chord.y, grid, get all the neighbors if grid neighbor. So if the neighbor is the same, then we do want to include it. What was it, C? Then we want to first set it to -2, just so we don't want to double count, and then we can add it to new garden. Oh, oops, this should be in here. Cool. And now if new garden dot size is equal to garden, that means we didn't add anything, so we want to break. Otherwise, we want to set garden equal to new garden. Cool, so now we have a set of coordinates that we care about. Garden is always empty. Ah, yes, garden dot add start. You know, that's actually an interesting point. That was, you know, my IDE telling me something. But you know, there's also cases where people use LLMs nowadays. Curious your guys' thoughts on that. I personally don't like using LLMs when solving, but I know some people tend to use it, and I don't know if I fault them. They seem to be quite good nowadays. Okay, focusing on, I'm actually going to write the cleanup part first, I think, just to get it out of the way. It's pretty easy. We basically just want to look for everything that's a -2 and set it to -1. You know, it's also pretty good. We should have a perimeter variable, right? I don't know why I'm using a long for that. It seems completely unnecessary. Yeah, if grid ij equal -2, we'll set it to -1, which means we're fully done with it. And to avoid looking at it, then we can return the size of the garden times the perimeter, right? Area times perimeter. Cool. Okay, now we gotta actually, you know, figure this out. So we basically, I think what we want to do is we're gonna do this using indices, so we don't hit the same coordinate. Mostly because I don't know if I ever implement dot equals for coordinates, so I don't want to hit that case. Garden, oh, but it's a set. Never mind, I cannot do that. Well, here's to hoping I did implement it. I probably won't take the risk. I should just do, we should start it at size times 4. Then 4L. Then we do this. So if C1, actually we don't, so if it's equal to C2 dot X, if C1 dot Y, let's just do math dot abs C1 dot Y minus C2 dot Y. So if this is 1, then we want to do perimeter minus equals 2. All right. The other case is if C1 dot Y equals C2 dot Y, then we want to do the math dot abs but flipped. So now we do it for C1 dot X and C2 dot X. Perimeter minus equals 2. Notice that this means we don't do it for when they're both equal. Cool. Let's give it a shot. 62,000. Well, it feels like vaguely in the right range. It is not the right number though. Cool. All right, let's take the small example, see what we get. 20. Yeah, that seems very wrong. Okay, cool. So now we can do something relatively simple though. Before we start flooding, we can do a quick grid print just to see what it looks like. Raise dot toString grid, no, row. Cool, so that'll print out the rows, and then we can also, right before here, system.out.line, this. Actually, let's do garden.size and perimeter separately. Cool. Okay, so we start with 0s, 1s, 2s, 3, 4. Cool. So we have 1, 4. That seems incorrect because it said 2 things. So how is garden size of 1? That one seems very wrong. Right? No? What? Wait, how are 2 things -1? But we only set, oh, we never, wait, what? Get neighbors. Huh. Okay, so wait, what is C here? Quick sanity check. C is 2, yeah, okay, that makes total sense. And for each coordinate, right. We need to add it all back in. Okay, 48. Does that seem right? Hello? Where is your thing? No, 140. Okay, we're still wrong. That's fine. So we have 4 times 4. Does that seem right? No. Region. Which region am I even looking at? Region. Oh, well, my regions are just busted, no? Oh, no. Here. 1, 2, 3, 4. Yeah. So, I'm double counting. Let's do perimeter minus. Right, because when we come across it once, it'll count it, and then when we come across it the other time, it'll also count it. Okay, yeah, well, there we go. Okay, cool. Yeah. That's why I really wish I could have done the other way, but with a set, you don't have indices. Kind of painful. Ooh, got a bulk discount. Instead of using the perimeters, use the number of sides. Yeah, that is much trickier to figure out the number of sides, right? Because, yeah, okay, how do I figure out the number of sides in an easy way? So first of all, let's just make this part 1. Okay, else. I guess we can do something similar, but do it for flood 2. Oh, but this is so tricky. How do you possibly... I mean, it's easy to visually determine the number of sides, but how do you determine the number of sides with the list of coordinates? I have no idea. How would I look at it here? So I have a grid here, right? So these A plants really kind of go all over, because it's both outside walls and inside walls. Huh. Okay, let's look it up. I'm curious how you actually could do this. Oh, it's not actually very helpful, huh? Interesting. I'm actually pretty stumped here. I mean, the area is trivial, right? We've already done area. So actually, yeah, let me copy over just the area code to start. So you start, you grab some stuff, and you break. Cool. So this is the area code. Yes, this is poor form to have so much copied code. But that's a problem for future me. Right? That should be a long. Cool, right? And then obviously I do still want the cleanup code. Although I should probably call this not perimeter. Let's do long sides equals 0. Then we can do times sides. Okay. So let's think. In what case would we add a side? So we start with 4 sides, right? And then we add any coordinate that's adjacent, and it would still be 4 sides. Huh. And then when we add another coordinate, we could stay at 4 sides, or we might increase to having 1, 2, 3, 4, 5, 6 sides. Yikes. But then we could also go down. Oh boy. This is so tricky. Like A is 4 here, but C is like 1, 2, 3, 4, 5, 6, 7, 8. Yikes. Wow, I'm so blanking here. This is crazy. It shouldn't be that hard to figure this out. Oh my goodness, I'm struggling so hard right now. What in the world? How can I possibly figure this out? Yeah, I mean, there's... Okay, the one saving grace is I think interior walls can be calculated by just doing the exterior walls of the inside shape. Oh, but how do you even know? There might be like 50 internal shapes. Yeah, that's pain as well. Okay, let's work on exterior walls first. How can we figure out exterior walls. So if we, okay, let's do the vertical walls to start, right? This is definitely like some day 8 problem last year where someone comes with some shoelace theorem nonsense. Okay, so if we go by, let's do, okay, vertical walls only to start. So you get row 1, we have some coordinates for, what? I don't even know how to begin this problem. This is crazy. Am I the only one struggling, or? Oh yeah, apparently I am. Well, not really. I mean, people's times were like 10x longer for this part. Okay, how could I realistically approach this problem? Let me see. Yeah. I don't know. Hmm. There's definitely some theorem for this. I just cannot remember for the life of me the name of the thing. I wonder if my own. No, this was probably 2022. I don't even think my blog has this. There was for sure some day where I do shoelace, and there's some very fancy trick that people used to do to get like a number of pipes or something. Ugh. No, I think that was just to calculate area though, but in this case area is actually really easy to calculate. That's probably not the right approach. Oh, okay, one thing I could do, right? I could blow this up, right? So everything, I add in like effectively the edges of every square. Yeah, okay. Let's try this. So we have a garden, right? So we have, let's call this garden 2. This is definitely not the right way, but I cannot for the life of me think of the correct way to do this. Okay, whatever. I think at this point it's better to just commit rather than keep looking like an idiot. So we shall do what I'm thinking. Basically, I'm going to expand every coordinate of garden into 4 coordinates. Now, what is an easy way to expand a dot into 4 dots in a way that preserves shape? We could multiply every dot's x and y by 2, but that wouldn't do much. That would preserve shape, but it would make 4 dots. Hmm. If there's a way to know if a dot was an external dot or not. Honestly, maybe I just need the grid back. Like, is this crazy? Yeah, what if I just replot everything onto a very large grid? Like, if I have a grid, I double the grid. Oh, okay. Sorry, I'm gonna be referencing things that you won't be able to see because I'm doing it on paper. I'm just trying to think of a easy expansion of a grid. I wonder if most coders just have a solution for this. Like, is this a well-known problem? Maybe. Oh, but it's so tricky for me. I am really struggling. Clearly not a pro at this, as unfortunate as that is. I'm really struggling out here. Sorry. Yeah, okay. I'm about to do something real dumb, but we're gonna just trace out the actual outline of the grid. So we're gonna make a grid copy. And I'm literally just gonna remove everything from it except the actual outline of the shape. Goodness, but this is only the exterior outline. I don't know what I'm doing about the interior outline. Yikes, yikes, yikes. Dang, I'm stuck again, huh? Okay. You know what, whatever. Let's just do the exterior outline. I have no idea how I'm gonna get the interior outline, but again, I feel like I'm just doing absolutely nothing here. I think that's kind of not the greatest spot. And I mean, that's the reality of it, right? Like, I wouldn't say I'm a bad coder, but I don't know a lot of algorithms. So when days get hard, you know, the problems will take a while. Yeah, apologies for that. Hopefully you at least get a bit of insight into my thinking process for these problems. But obviously, you know, if you know the way to do this, you're probably screaming at the screen right now, which is very fair. Okay, we're just continuing to go down these negative numbers. So okay, so everything is -3 except the stuff that's -2. Lovely. Okay, now we want to flood fill. But we want to flood fill from a point outside the grid. What's a good option? Okay, so the right is okay. The corners are not the same. Okay. Which means I can just have 2 corners. Cool. So if it equals it, we'll go with like the very edge. Again, technically this would cause it to fail if, I mean, if the whole thing was run region, this would fail. That's also such a trivial case. Okay, so now we have flood. And basically how we want to do it is we want to flood the board normally, right? So everything's -3, we'll flood it with -4, why not? Okay, so let's do this flood thing again, right? Oh yeah, we need a coordinate set to keep track of everything. Right, so while true, we'll make a new cache. Yeah, okay, we'll make a new cache. Cache.addFlood. Cool. And then for each coordinate, we get the neighbors. If the neighbor is -3, we make it -4 and add it. If the neighbor is -2, then we want to designate it something special. Again, let's just keep going negatives. We know there's no weird negatives. -5. Right, so we're deep into the negatives at this point. But yeah, basically, you know, we'll flood out the whole grid. And yeah, eventually break. So new cache.add all cache. New cache equals cache.size. Otherwise, we'll set cache. Okay. So now the whole grid. So cache is all exterior points. Grid is -4 for exterior, -5 for edge, -2 for non-edge, and -1, no, -3 for interior. Cool. The correct way of doing this, by this, is just to add in grid -1, -1, expand the grid out by 1, but whatever. Okay, so now what do? Well, we have the edge, right? Honestly, at this point, I don't trust myself. Let's revert to the simple case and just do a quick print. Goodness gracious. Alright. Quick print. Oh, this is never gonna end. One sec. I'm gonna do do? How about this? We add a counter. And we do that. That way it'll actually break. Oh crap, there we go. I don't want to do grid. Why am I doing grid everywhere? What am I doing? I haven't made a grid copy for a purpose and I never freaking used it. Well, I sure hope I didn't miss any grids in there. Okay. So this is the first one. -4, -4. Okay, that actually looks quite good. Yeah, everything else looks super weird, but that's fine. Oh my goodness, I just smacked my freaking keyboard. Okay, my bad. Yeah, everything looks really like this looks really promising. But like, what the hell do I do from here? Pardon the curse word. Thought I had something, but the more I think about it, the less I realize I don't know what I have going on here. This feels like such an easily solved problem. I don't know why I'm taking so long. Like, what are we even at? We've gotten 800 solutions. Yeah, I'm just missing something obvious, I think. Like, this feels like such a solved problem. How do you figure out the number of sides on a given shape? Like, the shape is freaking parallel. Like, all the sides are either parallel or perpendicular to the other sides, right? Like, should be so trivial. Maybe the key is to like scan all x's and y's. But like, what would that even do? Like, at each point, if I scan, you know, like 4, 3, 4, 5, right? Then what? Okay, well, at least that's an idea. All right, I don't have faith in this grid cache thing. I'm sure it's possible to make this work, but I have another idea. Okay, we're gonna do list integer revert. Okay, we'll do horizontal as well eventually. I really want to get vertical working. Then we can figure out the horizontal part. All right, so what we're gonna do is find all the vertical lines, right? And then we'll try to figure out, we'll try to figure out somehow if, I don't know what we'll do with them, but I feel like at least we can get them. Let's start simple, okay? So, basically, so we're gonna just literally loop through the entirety of garden. If chord.x equal I, what do we do with this? We could just directly add it. But I think we don't want to just directly add it. I think we want a left and a right. So that's what I'm going to do. I'm going to add temp.add chord.y times -1. and also add in the actual coordinate. The reason is I need a left and a right, right? And this feels like a one way to represent left and right. Okay. So if we're saying let's call this left, and this one can be right. Cool. So now we have a list, right? But we need to remove contiguous blocks. That shouldn't be too bad, because that means the right and left. Yeah, okay. So now this should remove, okay, if temp.contains, so if it contains j and it contains j, what is this, j times -1 plus 1. If it contains both, we want to remove both. Huh. No, this doesn't work. Okay, but we can do this. Let's start at temp.size -1 with j greater than or equal to 0, j plus plus. Right, so if this is a right wall, so if temp.get j greater than 0, if no, this doesn't work either. How do I remove pairs? This should be such a trivial problem, no? Like, what am I? Maybe if I do +1? Yeah, okay, so now what happens, so we might add like e.g. -1, right? And this one would be 1 plus 1 is 2. Cool, yeah, they shouldn't cancel each other out, but then if I had a -2 and a 3, that would perfectly work, right? That's cool. Right. Yes, okay, so let's do that. Then what we can do is new array list. Alright, so this should be able to list all the sides as well. Do I have a size variable somewhere? I could have sworn I had it. Ah, here it is. I'm gonna move it up. Okay, so now we have a second list, which is literally just gonna be everything in the first list that's not canceled out. So if it doesn't contain it, then you added it. Right? Okay. So now, what do we want? We want to set vert equal to temp2, I think. But also we want to do if not vert dot contains, we want to increase the number of sides. Right, so that should do all the vertical sides. Now we kind of just do this whole thing but for horizontal sides. So in theory, this could work. In practice, I'm sure this doesn't, but I don't know why it wouldn't. So give it a run. 72. What's the correct answer? 80. Okay, let's do a quick check. Not too worried. Let's do. Okay. So we have the A region has 4. Oh no, it's saying 2. That's not good. Oh, because I'm just adding the same. Wait. Okay, I gotta change the logic a little bit. That needs to be like that. This needs to be Y. This probably won't fix the core problem, but at least I can pretend to do something. Yeah, okay, that made it different at least. So C was C region 4A. That actually is correct, I think. Yes. Okay, and then D is 1 and is 4. That also is totally fine. Now these 3 are all whack. So let's do a quick check though. So we can do print line after vert. See how many vertical lines versus how many horizontal lines. So 4 vertical lines for C is completely correct. 2 vertical lines for D is correct. 1 vertical line for A is not correct. Why is there 1 vertical line? Let's print out vert, I guess, at each stage. So vert for A is 1, 1, 1, 1. Huh. Well, that's quite interesting. 1, 1, 1, 1, huh? Why would it be 1, 1, 1, 1? Ah, right, because, well, shouldn't it be 1, 1, 1? Oh, wait. 1. Ah, because if it's 0, it's itself. Right, that's actually quite bad. So we want to do something like this. Okay, 69 is still not right. But yeah, C. Okay, so vertical is now 2, which is correct. That's good. Oh, right, I have to do this for here as well. So we want to do this. This is plus 2, and this needs to be quarter plus 1. I could just do minus 1 at the end, but it's fine. 80. Oh, that looks promising. Okay. I mean, I don't have that much confidence, but might as well give it a shot, right? Like, it's, even if it's wrong, at least I can try. Cool. It is wrong. That's fine, because there's more examples here. So let's try this example. 3. Yeah, this is why I don't think I'm doing interior stuff correct, right? No, wait, I actually got that one. Okay, what about this one? So this one should be 236. Oh, I am getting 236. Okay, what about... Oh, I just did all of them. Oh, that's bad. Oh, no, this one. Wait. A larger example. Ah, here. Okay, what do you give? 1206. Okay, cool. So this is different. We're gonna remove that line. Okay, so let's do E, right? So E is 13 times 8. Perfect. F is 10 times 12. Cool. C is 14 times 22. Yep. J is 11 and 12. Yep. C is 1 and 4. Wait, what? C is 1 and 4. Oh, okay. There's multiple C's, I guess. Yeah, cool. S is 3 and 6. Yep. I is 14 and 16. Yep. I is 4 and 4. Yep. R is 12 and 10. Yep. V is 13 and 10. Wait, what? Weren't all of those right? Oh, did I miss one? I missed M. Where did M go? Oh, where's M? No, M definitely exists. I just don't do M somehow? How's that even possible? What? Wait, what? Like, M just isn't here. Straight up does not show up. Which is crazy, right? Like, how can something just not show up? Yeah, I mean, clearly that's wrong. But why does it not show up? I'm not sure. I mean, it's not a particularly weird region, right? It's just there, yeah. Okay, let's see what's gone at the end. Yeah, I mean, this area is looking gone. Let's do a quick check. Char of C plus A. Do we ever see M in here? Not you. There's M there, but there's no M here. Like, V is the last one. Which is crazy. It just stops. Also, this is working, so I can get rid of this nonsense. Why would it be different? Like, I would have expected the two parts to run identically for that. But I know it's the last one. Oh. Oh yeah, wait. The grid at the end has things. Huh? But it returned? Val equal -1 break. So Val did give -1. What in the world? I mean, there's clearly values here. Right, like I'm getting here, right? Okay, that's a lot of hellos. Oh, what? I never even hit the -1. How is that remotely possible? Oh, because I just added literally everything to the wrong frickin' class. That's why. Oh, that is so bad. Okay. And not the lock class, the wrong method. So hello. V. And then after V returns, it just gives up. It never even hits this case. How's that possible? Nothing should be returning -1 then. Like, how is it possible we're getting a return of -1 here? Oh, because of my freaking counter. Oh my goodness, that really bit me in the butt, huh? Yeah, there we go. Wow, that is dumb. That is entirely my stupidity. I should get rid of that print statement. Where is it? Let's get rid of a bunch. Oh, let's finish before I got rid of the print statement. That's fine. Nice. Oh my goodness. Yeah, the counter thing really bit me. Well, yeah, almost a full hour for today. I mean, some of it was definitely me. I did worse between the two parts. But also, this did feel like a relatively hard part two. I guess we're starting to get into the, middle days. Probably I'll start taking a little longer on these as well. Hopefully not an hour every day, but yeah, see you tomorrow.